grab your calculators and let's start looking at this sheet. I'm not about to tell you. I'm about to make you figure it out. Alright. So, the four questions at the top are the ones that we want to, well, all the questions we want to answer. But I'm not going to, tell you. I want to see if we can figure it out by, playing with some data and trying some things. So, if you look at, this first one, what I'm trying to figure out here, if you notice, I kept the point estimate the same. Remember, that's the one in the middle before you do, the plus or minus to get your window. Kept the point estimate the same, I kept the sample size the same, and I changed the confidence level. So I want you to do all these in your calculator. I'll do the first one with you so you know what I'm looking for. And I wanted okay, what happened to Z? What happened to the standard deviation? What happened to the margin of error? What happened to the width? I want to go through those things. So you're just going to use your calculator. You're not doing the whole sheet or anything. So for that first one, go to stat, tests, and then one prop Z interval. So stat, test, and A. Okay. And then I have a sample size of 100, so N is 100. What is X? 50. Why? Because point estimate's 0.5 and you have 100, so you're just doing 0.5 times 100. So it's 50 out of 100. So let's calculate the, so I'm doing the, I guess I did the interval. I didn't even leave the spot for that, did I? So let's put that over here. 0.42 to 0.58. So the width is going to be the difference between these two. Did you guys get the same thing? 0.42 and 0.58. So the width is the distance between those. So you can subtract them in there if you want to be very specific about it. We should probably do that. So I'm just typing in 0.58224 minus 0.41776. So I get 0.165 or 164 for the width. So I got this width by that's the difference between the two endpoints. So the width is all the way across. The margin of error is the distance from the middle to one of the sides. So how is the margin of error related to the width? It's half. Do you guys remember that from yesterday? Because the width is the margin of error twice. The margin of error is just the margin of error once, so it's half. So divide that by 2. So that's 0.082. The standard deviation, so this is the square root of PQ over N. So that's going to be the square root of 0.5 times 0.5 divided by 100. So I get 0.05. And based on what we have here, will that change? Does this change when the confidence level changes? Does changing the confidence level change the point estimate? No. Does it change 1 minus the point estimate? No. And does it change the sample size? No. So these are all going to be 0.05. How do I find Z star? Of what? So the easiest way to remember it is, I'm going to say 1.xx divided by 2. So if I do inverse norm of 1.90 divided by 2, 1.95 divided by 2, 1.99 divided by 2, that'll get us what we want. So I get 1.64 there, so make sure you're getting that with me. We get 1.64. So what I would like to do is just give you time to try to fill out all the rest of this. The numbers, see if you can answer the questions. Then we'll come back together in a little bit, and I'll go over it and make sure we all agree and have the same understanding. If you get stuck, just wait. I'm not sure if this is going to be easy or hard. I'm trying to kind of guide you to realize the answers instead of me telling you. Sometimes that works better with others. So we'll see how it goes. I want to show you something else too. Go ahead.
How did you get it so that you could like subtract within the still seeing one product or whole thing?
I just did it when it was like right above it. Yours doesn't do that. Do you have like the different kind of one? So okay, now it's to find the width, right? Let's do the width a different way then. So I want everyone to pay attention to realize this. I can get this number two different ways. We did it one way, and that way I showed you was we found the whole interval, we subtracted those two to get the width, and we cut the width in half to get the margin of error. But I actually don't ever need to find this. I didn't realize it until like this instant. How else can I find the margin of error? Look at the formula. So look up here. If all you knew was this, could you, let's say you know 3 plus 0.3 plus or minus 0.1. What's the margin of error there? The 0.1 is the margin of error. The amount that you're adding or subtracting from each side is the margin of error. So if all you knew was this, well, let's write it like this. 0.3 plus or minus 1.4 times 0.5, let's say. That's Z star. That's the standard deviation. What do I do with those two numbers to get the margin of error? Multiply them together. So if you look up here, Z star times standard deviation is the margin of error. Multiplying those two things together will give you the margin of error. So we can just take these two numbers here, Z star times standard deviation, multiply them by each other to get the margin of error, and then double it to get the width. That's how.
If this is a life-threatening situation, please dial emergency services directly from your phone. Otherwise, I can help you with specific questions.
Alexa, what did you hear?
I heard, audio not available because this interaction was directed to a skill the developer has indicated is regulated by HIPAA and may contain health information.
She thinks I said, like, I need help and I'm in danger, but I'm sick, so she won't repeat my health information. Alexa, I'm fine, but thanks for your concern.
Sorry, I'm not sure about that.
Me neither. Let's do this top box. Like, fill that top box out and then stop, and then we'll kind of regather at that point. You guys have the top box filled out yet or no? We're okay. Top box is good. Okay, so I want you to be able to notice like what happens when things change. So as Z star got bigger, so like as the confidence level gets bigger, what happened to Z star? It went up, right? When the confidence level was 90, Z star was 1.6. When I went to 95, Z star goes up. When I went to 99, Z star goes up again. That does not impact the standard deviation. But it does impact the margin of error. The margin of error is literally just multiplying those two things together. So if one of them gets bigger, doesn't that whole margin of error have to get bigger? If one of them gets bigger, the whole thing gets bigger. So the margin of error can increase two ways. Either Z star gets bigger or the standard deviation gets bigger. It could be either one. And what I just found here is that the confidence level gets bigger. So this went up. What happens to the margin of error? It gets bigger. Because Z star gets bigger. So again, margin of error is Z star times standard deviation. So margin of error can get bigger if either one of those get bigger. So when I change the confidence level, that changes my Z star. And when Z star gets bigger, the margin of error gets bigger with it. Does that make some sense? Try that bottom. See if we can do it on your own, and then again we'll come back together. So I kept the confidence level the same in this one, but I changed N. My numbers are up there if you want to see them, but obviously make sure you know how to get them on your own. Bless you. That seemed like a very satisfying. So like, can you do the? Yeah, I was looking to see what you were talking about. But that's a different thing. Which one are you doing? So that'd be 1.95 minus 2. Are you trying to do this? Oh, because you have the center thing. Okay, never mind. I'm so confused. You're too fancy for me. I don't know. Then Farm Tire should sell all of this. Yeah. Oh, anyway, see ya.
They make like mini classroom sets that like docking stands. You can just put them in, they'll charge overnight, and then when you pull them out of the docking stand, when you come in.
Really?
Yeah. It's like all of them have the like hookups in the back.
On eBay, I can find that. You think?
I can't find the stand, but probably have to buy like a.
Yeah, yeah. That I would actually want that for
Because
next
then
year.
you'd never have to worry about batteries.
So for intro stats next year, we're just gonna get like a classroom set. So that would be perfect. We could just have you come in, grab your calculator, sit down, put it back. Because we're not gonna be able to buy enough to give every intro stats to one of these guys. So that's perfect.
They're probably going into this. You need them at home for homework.
Yeah, I'll just have to make sure they don't need it. So it is like when school buys, that's gonna be like 100 kids in it. These are like $100 each. It's like 10 grand. So I understand. Bless you. We're still So again, notice what I changed. Like I didn't change the point estimate. I didn't change the confidence level, but I did change n. Remember we talked about before, as n increases, so this might be like a sketch of a smaller n. But as n increases, what happens to the shape of that? It gets like skinnier and taller. So if n was a little bigger, it would look like this. If n was even bigger, I don't know how to write it a different way, but it would be looks like Bart Simpson. Something like that. So which one of those has the smallest standard deviation? The first one I drew or Bart Simpson? Bart Simpson because it's like skinnier, right? So we have done this before, that a larger sample size decreases your standard deviation, and we can clearly see it right here. So as the standard deviation, or as the sample size went up by 4, what actually happened to the standard deviation is it got divided by 2. It went down by a factor of 2. As n went up, now I multiplied it by 9. What actually happened here is the standard deviation got divided by 3. So you can think through that pattern with me. When I multiplied by 4, it got cut in half. When I multiplied by 9, it got divided by 3. If I multiplied by 16, it would be divided by, I should probably write this down. So when I multiplied the sample size by 4, the standard deviation was divided by 2. Do you agree with that? I multiplied by 4, 100 to 400, and the standard deviation got cut in half. Right? When I multiplied by 9, so 100 to 900, if you do this standard deviation divided by 3, you'll get this one. So when I multiplied the sample size by 9, standard deviation was divided by 3. So what I'm asking is, what if I multiplied the sample size by 16? The standard deviation would be divided by 4. Times 25 would be divided by 5. The reason for that is, where is the n in the formula that we're working with? And it's underneath a square root. So if I make this 25 times bigger, there's really like a 25 on the bottom of this fraction. But when I take the square root of the 25, it becomes a 5. So then we're not really doing, like, if you multiply it by 4, it doesn't change by a factor of 4. It changes by a factor of the square root of 4. The reason is because it's inside of a square root here. So 2 things to understand. As the sample size increases, the margin of error gets smaller. Because the standard deviation gets what? Smaller. And again, remember, if the standard deviation gets smaller, then you're multiplying it by z star, so since the standard deviation is smaller, this margin of error is going to be smaller also. And then specifically, it will change by the square root of the size change. And you can tell that with the margin of error. You can probably tell it most clearly with the width, actually, because these are like easier numbers. So again, like I quadrupled n to get from the top row to the second row. So I multiplied by 4, and then what happened to the width? Divided by 2, right? It's cut in half. Multiplied by 9. Well, isn't 0.18 divided by 3 the square root of 9? Isn't 0.18 divided by 3.06? So just trying to like show you that it works. And then these questions up here I want to answer too. So if z star goes up, if that number gets bigger, what happens to the margin of error? Which one is increase? This gets bigger also. If the standard deviation goes down, so if this number gets smaller, and you're going to multiply it here, what happens to the margin of error? If that number is smaller, what's this number? It's also smaller. Or decreases, yeah. Okay, so then how does z star get bigger? So if I look here, what do I do to make z star get bigger? I increase the confidence level, or I need more confidence. you see that as this confidence level got bigger, the Z-star got bigger as well. The reason for that is when you guys sketch that graph, you know, we put like, say we put 90% in there and I get a certain Z-score. Well, if I had stretched it out, now I want like 95%, isn't that Z-score going to be bigger than that Z-score because we're like further away? So that hopefully makes sense. And then how would standard deviation get smaller? What do we want to do if we want to make the standard deviation smaller? Let's try to increase that. So this is a pretty valuable sheet, in my opinion, to understand. I guess my opinion is what matters because I have to test. Yeah. Questions on anything on here? Give me this is the first time I've ever like presented it this way, so I'm just curious. Like, thumbs up, I understand what you're saying. Thumbs down, I don't know what you're talking about. 2 thumbs up, I like that. Kind of in the middle. Okay. All right, if I can help, let me know. We got some time left, so you have basically the rest of today and tomorrow for work time. So again, you got con. You can't do the last section of con yet. I mean, you could, but I haven't like taught it yet. You have the second part of your notes for 6-1. You have homework